Hello everyone, my name is Andy. I work at Pivotal Labs in New York City, and today I will give you a quick introduction to CRuby source code. First I'm going to tell you why you even should consider looking at CRuby. Then I'm going to give you a quick overview of the Ruby source code, and at the very end I'll show you how you can hack it and play with it. Okay, so what is the motivation? I think all of us, if we have been doing a Ruby for a couple of years, there's a certain plateau that we reach when we are not learning anything new. And if you want to truly understand the Ruby's object model or metaprogramming or even garbage collection, you should take a look at the C source of Ruby, because a lot of your answers will be, a lot of your questions will be answered, and also you will have this epiphany moment where you actually will see what code actually does all this, like singleton methods and ghost classes. What's happening behind the scene, behind the curtain. You can also consider C if you're working on an application that's written in Ruby, and let's say it does some data processing that's a little bit slow in Ruby, because I think we all know that Ruby is sometimes a little bit slower if it comes to large data processing. What you can do, you can write 99% of your application in Ruby and just rewrite the critical sections, the heavy lifting, heavy computational parts in C, and then you can get 10 to 50 times faster code. And I'll show you actually how to do it. It's also great to look at CRuby if you want to write C extensions. So for example, Nokogiri and Psych, they all are actually C extensions that take advantage of Linux libraries like libxml and YAML. You can also consider combining Ruby and C, and then you pretty much have the best of both worlds. You have Ruby productivity, all the testing frameworks, so you can test your code using RSpec, but you can still write your algorithms in C and get all the benefits of C, like efficiency, speed, and algorithms that were already written in C. So at a high level, you have high-level modeling in C, coordination of algorithms, analysis, and scripting, and on the low level, you have all your algorithm implementations, manipulation of in-memory data structures, and even integration with standard mathematical libraries like LabPack, and etc. Okay, so let's start level 1, which is building our Ruby from scratch. The first thing that you have to do is to simply check out Ruby from GitHub. And just for safety, I checked out this stable release tag 247. So the results are repeatable. If you're on Mac, the first thing that you should do is install OpenSSL, because you will need it for Ruby gems. Then you run this command autoconf, which actually configures the source code of Ruby for your particular machine. And the last step is running this configure utility, where we specify the prefix, and we set it to my Ruby in your home folder. This is where your Ruby from scratch will be installed to. Then you specify optimization flag with 0. We pretty much disable optimization, because if you want to hack and explore Ruby source code and compile binaries, that makes debugging easier, because if there is optimization, then debugger will start jumping to different lines of code. It will be unpredictable, but if you disable optimization, everything will be easy to debug. And the last thing is we add the G flag to make sure that all the binaries that we will build will include C-level debug information. After you run configure, this is just for your reference. This is what you should see in your terminal. If you're on Linux, the process is pretty much the same. The first thing you have to install libssl, run autoconf, and configure your project. The only difference is the debug flags are a little bit different, because on Mac we are using LLDB, and on Linux we usually use GDB. So we just add G3 and GDB to include better debug information, C-level debug information for GDB. once you have your source code configured, the next thing you have to build it. So you just run make, which is just like running rake. And this will actually compile all the sources, and will also link them and build libraries. In the build folder, you will actually be able to find Ruby binary now. After you build the binaries, it's a good idea to actually run all the unit tests using make check. Actually, CRuby comes with very comprehensive unit tests. You can see here there's around 13,000 tests. From my experience, if you check out that 247 flag, and you follow all the steps, I tried it on 2 computers, they all should be green, you should be fine. If you get a couple of green tests here, that's red tests here, it's fine. But if majority of them are failing, you should probably try and redo it again. Follow all the steps and you should be fine. After you make sure that your Ruby is actually correctly built and it works well, you can install it, and you can do it running make install. And this will actually copy. You can see here that actually copying binaries into my Ruby folder. It also is setting up a gem folder structure, and it even installs a couple of default gems for you. Once you installed our Ruby from scratch under my Ruby folder, you still have to inform the shell where everything lives and where the gems are and where the binaries are. So the first thing you have to do in your terminal is set the path to make sure that bin under my Ruby is the first one. Then you have to configure gem home and gem path to point to your my Ruby folder. So at this point, your Ruby from scratch is pretty much set up correctly. And it shouldn't interfere with any of your RVM or RubyEnv setup. To verify it, you just run which Ruby, and then you can clearly see that it's from my Ruby. You can even run IRB, and when you raise inside of it, you should see that it's actually running the one from my Ruby folder. Okay. The last part is actually verifying that gemenv is correct. So if you run gemenv, you should see that all the folders that are referenced by the environment are pointing to my Ruby. If you list your gems, you will just see that we have a couple of default gems after installation. And obviously, a good test of our newly compiled CRuby is to install Rails, because it has a lot of dependencies and there's a lot of going on there. So it's a good, really stress test for our installation. And after you install Rails, you should actually be able to create new Rails app and run it. And here, you can see that you will have a fully complete CRuby installation that you compiled on your own from source. And that's not very impressive. But what's impressive is that you can now change all those C files at your will and experiment with CRuby. Even if you're running RubyMine, you can just simply go to settings and set SDK path to my Ruby, and you should be able to use it in RubyMine. Okay, so that completes level 1, which is within 30 minutes, you can install a Ruby from scratch on your machine and be ready to use it. Okay, because we will be, when you change things like CRuby, or you hack it, or you make a lot of changes to it, it's a good idea to have debugger set up. So there's a couple of options. These are C-level debuggers. So you can use LLDB, GDB, or even Xcode. And there are plugins for Vim and Emacs. This is an example on Mac. This is how we would actually debug, and this is C-level debugging, debug a simple puts hello uppercase script using LLDB. So the first thing that you should do, you should just load the Ruby binary with the upstring RB script, and then you set breakpoint at the beginning of the string uppercase method. And when you run it, your screen should look something like this, where you can actually see that we loaded the upstring, and we actually broke at the first statement of the upstring method in Ruby Ruby string class. So here you can see that you can actually now debug internals of Ruby. So this is good also for cases when you have in production, let's say, seg faults. This allows you to actually debug and figure out what's going on. You can even use Xcode to debug your CRuby code. This is an example. I think we are debugging array.push, a hash push here. Okay, so now we have CRuby and we have debugger set up. Next thing is let's do actually quick overview of the folder structure and of the whole C code base of CRuby. Let me just switch to Vim. Okay, so here you can see that oops. Sorry about that. All right, there you go. Okay. It's going to be a little bit difficult, but I think I can manage. Okay, so here is the, this is the folder, CRuby folder that I checked out, right? It has a lot of subfolders here, but don't worry about any of them. They are not really important, except this one, extensions, that I'm going to tell you about in a second. And you can see here that most of the files that we care about are in the root folder, so you don't have to go into any subfolders. So for example, Ruby array class is actually defined here in array.c. You can also find things like string. All your major classes are actually defined in the root folder. So it's very easy to figure out where the stuff is, and you can start looking at them and just trying to reverse engineer what's going on. There's not a lot of documentation, but the code is written in such a way that's very easy to understand. And once you know, as long as you know a little bit about Ruby, you will be you will feel like at home. Okay, so let's take a look at something simple. For example, fixnum. Right, so I'm going to find that fixnum is actually defined in numeric file. Okay, there you go. So if you look at that file, the structure of the files is actually almost identical. At the top, you have a couple of includes. You don't have to worry about it. There is a couple of macros, C macros, and pretty much the majority of the file are definitions of the functions. Definition of C functions that are actual Ruby methods. And at the bottom, you can see here, there's always this init method, which you can, let me just switch this to mirror for a second because this is not going to work for me. Sorry about that. Okay, that's good. Okay, so now it should be faster. Sorry about that. So here you can see that there's this init method that basically initialize all the classes. And array has it, a string has it, everything else has it. And if you look here in the middle, there's actually definition of the, if you ZT it, you can see that there's definition of the fixnum class. So you can see clearly here, right, that we have some, so we said fixnum, we use define class with its name, fixnum, and it inherits from an integer, right? And the next thing that we are doing, we actually define method on this fixnum class, which is toString, and it's actually implemented by this fix2s C function. You can even see that there are things like defining aliases, defining methods, etc. So it's very easy to follow. If you know the classes, Ruby classes, you shouldn't have any problems with actually understanding what's going on here. Let's take a look at let's say, an array. So this is the array class. The structure of the file is exactly the same. In the middle, you have, at the top, you have a couple of C macros. In the middle, you have all the definitions of the methods in C. And at the bottom, you always have this init method that pretty much initializes the class. And here you can see that the pattern is exactly the same. We define a class array that inherits from an object, which is equivalent to basically defining class array. Then we include a enumerable module, we define a lock function. This is the only difference, because in Ruby, we actually, when we do a class name .new, the step of allocation and initialization is actually the same. But in CRuby, when you actually do it, there's a two-step process. First, you allocate the memory for the object, and then you call initialize, which is the initialization process. You can even see here that we have this define singleton method. If you ever explored Ruby object model and metaprogramming, you should be aware that there are singleton methods. And this is pretty much what's happening when you're defining a singleton method. So if you really want to understand how Ruby works, digging deep into CRuby source code will help you a lot. Okay. So that's pretty much folder structure, right? Very easy to follow. I showed you fixed num. I showed you string. I don't think I showed you string, but it's exactly the same. You can see here, the first thing that you do, you define class a string that inherits from object. Then you include a module comparable. You define a lock method, singleton method, and all the other methods. This is the array. So class definition, if you want to define a class from scratch in C, you can actually do it. And most of the built-in classes that come with your Ruby installations are actually implemented completely in C. And this is pretty much how they are done. Okay, so let's start small, right? How would you add a new method to, let's say, built-in array class? Right? It's a two-step process. For every definition of a method, it's a two-step process. First, you have to use this helper method that comes with CRuby, which is rbDefine method. You specify the class that you want to add it to, the name of the method, the pointer to the function, C function that actually implements that method, and number of arguments. This 0 is a little bit confusing because you can see here that the implementation actually takes one argument, but every every function in C that implements a Ruby method takes at least one argument, and this is pretty much yourself, right? This is the pointer to the object that you call that method on. So there's at least, if it says 0 here, if you say there's 0 parameters, it's 0 optional parameter, 0 extra parameters here, I would call it. And this is simple implementation of the, let's say in this case, length method on array, right? So if you're calling length on an array in your Ruby code, pretty much you're executing this code. Okay. So when you are working with CRuby, you have to remember that there are two worlds. One is C and one is Ruby. And when you're in C function, you have to remember that you always work with direct access to memory. There are pointers, etc. And you have to malloc and free all your memory. So there's no garbage collection. When you're working in Ruby, you are working with heap and objects, and all the memory is pretty much taken care of for you by GC. So every time you cross the boundary from Ruby to C and back, you have to remember to convert those types. So for example, here, if you are calling a method and you are passing in a fixed num, and you want to use it in C, you have to convert it from fixed num to equivalent long value. And there are actually convenience macros, num to long, that actually will do it for you. And if you want to go back, for example, because you are returning something from your C function, well, you can convert it back from C long type to Ruby fixed num. And you can use this long to num conversion macro. These are all the types that are defined in CRuby. So you can see here that pretty much they're all familiar, right? What's interesting is that actually true and false are actually defined as separate types. Okay, that's really completes this section of my talk, which is we looked at the folder structure. It's not that scary. Everything is in root folder, right? We also look at this simple implementation. We looked at this sample array and string implementations. We also learned how to define a method, and we also now know how to convert data between C and Ruby and vice versa. Okay, so let's take a look at a couple of examples. So let's say we want to add a Fibonacci method to fixed num, right? If we were working in Ruby, we would just open the class and define a method, right? And this is an example how you would do it in pure C. So, you know, you take a long, you do something with the longs, you compute all the numbers and then return long. The thing is that you cannot really use this code directly because it only knows about C data types, right? So you have to massage it a little bit so it's aware of Ruby data type conversion. And this is how you do it. Like this, we start with a pure C function, and this is how you convert it to the CRuby convention. So first, input, right? Like every algorithm, input, processing, and output. You have to convert at input. So you have to convert it into a proper CRuby signature. So it returns an object, and it takes an object self, reference to self. So this will be the fixed num that we call the function on. And then we do some processing. Every time we access a Ruby object, we have to unpack it into C type. And when we return data back to Ruby, well, we have to convert it back from C type to Ruby type, right? It's not really complicated. Usually, what you definitely have to do it at the beginning and end of the method, and you know all the places where you need to access the data. And the last thing that you have to do is actually define that binding. Define that on the fixed num cfib is actually implemented by that function. Okay, I can show you that actually in. I think I have it running here. So if I Control Z and I run IRB, you can see here that, for example, 10 class is a fixed num, right? And I think I can call cfib on it. There you go. And 10 Fibonacci number is 55. So you see, I'm running straight Ruby from the command line, and that function is there. And this is how we can pretty much change or play a prank on someone by, for example, switching like plus and minus calls. So it's a good way to prank someone, but it's also a good way to learn about Ruby, right? You can see that you can make that connection. You can make it fun and entertaining, but you can make connection between actually what we write in Ruby and how it's done. Okay, next. I think I have next example. Okay, so what's the benefit? Like, obvious benefit is actually performance. If you look at this implementation, test of this implementation, so I calculate 1,000,000 times fib80 using plain Ruby implementation and CRuby implementation, and you can see that Ruby takes 26 seconds and C takes less than a second. So CRuby is 30 times faster. And if you look at this implementation, right, honestly, I can probably rewrite it in a couple of minutes, right? And I can get 30 times faster code. I don't think this is a good idea. It's a good idea to rewrite your whole web application this way. But if you have a crucial code, right? If you use certain algorithms that are already probably written in C, you can speed up your code a lot. And I show you later on that how you can actually speed up, like, for example, something as simple as sort 10 times. Okay, so next example is just simple prime, right? Prime test. The same thing. Here is the equivalent Ruby version. Here's equivalent CRuby version. We do all the conversions. Like we pass in value self. Every time you see a value, think about it as it's in basically reference to a Ruby object. And you define the binding. And the performance, again, you know, like we test really large prime. If it's prime, it takes 30 seconds in Ruby, and it takes 2 seconds in C. C is 17 times faster in this case. Okay, so we can even go farther. So for example, this is a special case for an array. In Ruby, our arrays, pretty much you can create Ruby arrays of any object, but you pay a pretty much performance penalty for that. So if you, for some reason, want to sort millions of numbers, well, maybe it's a good idea to actually create a C implementation of C-long array. So you see here that we define a class, C-long array, that inherits from an object. We define alloc function for it. And then we define all the methods, right? This is how we initialize our constructor, quicksort that actually does quicksort on our numbers, and a square bracket accessors. So this is the allocation method. This is the method that actually allocates memory for our new objects. Every time you call C-long-array.new, this will be called. And we take advantage of this data make struct. This is something that CRuby provides to you, and you just have to provide the type of structure that you want to allocate, and it's going to do all the work for you. And it will give you a pointer to that memory location as a return value. So this is how we actually define our array. It's a simple pointer to list basically an array of longs, and it has also a size. This is actually the constructor, the proper constructor. So every time you call C-long-array.new.10, 10, this is what will get called. So you see that size is actually passed in as a parameter. And here you can see that we use this data get struct. This is so we can get the pointer in memory of the Ruby object that we are working on. And this Ruby object is actually our array. And then what we do is simply malloc enough memory to keep 10 elements, and we set its size. This is the accessor, right? I think you can see the pattern that yet again we use the same function, data get struct, to get the address, in-memory address of that structure. And then we just convert the passed-in values, and we set the element of the array in C. This is the setter, which is almost exactly the same except for this line. Instead of getting, we're actually setting that value. So this is the quicksort. So this is a good example how we can actually write a CRuby adapter for pure C function. So this adapter function actually, what it does, it gets the address of our in-memory object and passes it directly to pure quicksort array function. And this is the pure, plain and trivial implementation of quicksort that you can find in any like algorithms books or something. It knows nothing. What's interesting is it knows nothing about Ruby. It doesn't even care that it's run from Ruby, right? So you can get a lot of algorithms that were written 10 years ago, 15 years ago, that were not even intended to be used in Ruby, and you can use them in Ruby, and you don't have to reinvent them or even rewrite them in Ruby. I think it's faster to actually use CRuby to reuse those algorithms than actually rewrite them in Ruby. So the performance, so it's a trivial example, right? We are using also very simple quicksort implementation. And just because we rewrote it in C, it's 10 times faster. It doesn't really matter if you're sorting 15 numbers, right? But if you are sorting millions of numbers, 10 times faster might be something, maybe a difference between something that was worth doing or not. Okay, so that pretty much makes completes the fourth level. So now you should be able to create your own new class, and play a prank on someone, I guess, with fixnum when you swap some of the methods. And you can see that most of them are actually at least 10 times faster. I have another level that talks about graphs, but I don't have enough time for it. But you can download my slides and actually see here. I'll just show you that when you're working with graphs, you can get like 50 times faster execution, or 19 if you're doing breadth first search. Okay, so what's important to remember about this talk is, I think the most important thing to remember is that CRuby is not really scary. Within half an hour, you can have a working installation that you can hack and play with. And you can use it to learn more about Ruby, especially if you're a little bit tired of like coding in Ruby for 3-4 years. Because you can discover new layers, hidden layers, and you can even do some crazy stuff like multiple inheritance. Obviously not in production, but you can also learn more about metaprogramming, and you can, if there is a need, you can, if someone tells you that your application is slow in Ruby, well, maybe the best solution is just, rewrite some of the slow bits in C, and there's no faster way to code, right? C is pretty much the fastest. Okay, last note is Pivotal is hiring. We have, offices pretty much in every city, so any questions? All right, that's it. Thank you very much.